Assalamualaikum and hi, my name is BATRISYIA binti ABDUL and I am from AFO AS120125. Today, I will be presenting about oxygen. Firstly, we need to know what is oxygen. Oxygen, non-metallic chemical element of group 16 of the periodic table. Oxygen is a colorless, odorless, tasteless gas essential to living organisms, being taken up by animals, which convert it to carbon dioxide. Plants, in turn, utilize carbon dioxide as a source of carbon and return the oxygen to the atmosphere. These are the element properties for oxygen. Oxygen was discovered about 1772 by Swedish chemist Carl Wilhelm Scheele, who obtained it by heating potassium nitrate, mercury oxide, and many other substances. And English chemist Joseph Priestley independently discovered oxygen in 1774 by the thermal decomposition of mercury oxide and published his findings the same year, 3 years before Scheele published. In 1775 to 80, French chemist Antoine Laurent Lavoisier, with remarkable insight, interpreted the role of oxygen in respiration as well as combustion. Discarding the phlogiston theory, which had been accepted up to that time, he noted its tendency to form acids by combining with many different substances, and accordingly named the element oxygen, from the Greek words for acid former. At 46% of the mass, oxygen is the most plentiful element in Earth's crust. The proportion of oxygen by volume in the atmosphere is 21%, and by weight in seawater is 89%. In rocks, it is combined with metals and nonmetals in the form of oxides that are acidic, such as those of sulfur, carbon, aluminium, and phosphorus, or basic, such as those of calcium, magnesium, and iron, and are salt-like compounds that may be regarded as formed from the acidic and basic oxides as sulfates, carbonates, silicates, aluminates, and phosphates. Plentiful as they are, these solid compounds are not useful as sources of oxygen. Separation of the element from its tight combinations with the metal atoms is too expensive. Oxygen has two allotropic forms, which are diatomic and triatomic, or ozone. The properties of the diatomic form suggest that 6 electrons bond the atoms, and 2 electrons remain unpaired. Accounting for the paramagnetism of oxygen, the 3 atoms in the ozone molecule do not lie along a straight line. Ozone may be produced from oxygen according to the equation. Thermal decomposition of certain salts, such as potassium chlorate or potassium nitrate. The decomposition of potassium chlorate is catalyzed by oxides of transition metals, manganese dioxide, is frequently used. The temperature necessary to effect the evolution of oxygen is reduced from 400 degrees Celsius to 250 degrees Celsius by the catalyst. Thermal decomposition of oxides of heavy metals. Scheele and Priestley used mercury to oxide in the preparations of oxygen. Thermal decomposition of metal peroxides or of hydrogen peroxide. An early commercial procedure for isolating oxygen from the atmosphere or for manufacture of hydrogen peroxide depended on the formation of barium peroxide from the oxide as shown in the equations. Electrolysis of water containing small proportions of salts or acids to allow conduction of the electric current. Physiological uses of oxygen. In cells, oxygen is needed for aerobic respiration, which allows for the extraction of energy from ingested foods. Thus, supplemental oxygen at home and in hospitals is vital for those with breathing disorders such as emphysema. Compressed oxygen tanks are used by mountaineers at high elevations to counteract the decreased O2 pressure at these altitudes. Supplemental oxygen is needed for surgical patients intentionally rendered paralyzed for medical procedures, in which heart-lung machines keep their vital functions going. Oxygen can be used as a sterilizing agent to kill certain anaerobic bacteria that are killed by sufficient exposure to the gas. Industrial uses of oxygen. Oxygen is needed for the reaction that converts carbon to carbon dioxide gas in steelworking, which takes place under high temperatures in a blast furnace. The carbon dioxide produced allows for the reduction of iron oxides into more pure iron compounds. Oxygen is used in other applications involving metal and requiring high temperatures, such as welding torches. Aerospace uses of oxygen. In liquid form, oxygen is used widely as an oxidizing agent for use in missiles and rockets, where it reacts with liquid hydrogen to produce the terrific thrust needed for takeoff. Astronaut spacesuits include a nearly pure form of oxygen. Oxygen is used to degrade hydrocarbon compounds, which are broken apart by heating them. This is used to create combustion that usually liberates water and carbon dioxide, but it can also produce the hydrocarbons acetylene, propylene, and ethylene. Oxygen is used in sewage treatment and water purification plants. It is forced through water to increase the production of bacteria that metabolize waste products in the water. Oxygen gas O2 is needed to produce energy in tanks not linked to an electrical supply of their own, such as generators and vehicles. For examples, ships, airplanes, and cars. I think that's all from me. Thank you.